Right. So in multiplication, before going into multiplication of vectors, I'll just introduce what is mean by a vector. Then I'll continue with multiplication. Okay. So here, so already we defined when we discussed about addition of vectors, types of vectors. That once again I'll just introduce what is mean by vector and I'll continue. Right. So vector means what? Any physical quantity, whatever may be the physical quantity, the measurable physical quantities. If the measurable physical quantities having both magnitude as well as direction. So such a physical quantity can be called as a vector. Okay, so any physical quantity which has magnitude as well as direction. And one more condition we imposed when I described about vector, that is vector quantity, if it is there, it should obey vector law of addition. Okay, vector law of additions I have completed previously only. So it should obey vector law of addition, then only it can be treated as a vector. Now, so basic things are what? It should have direction as well as magnitude. So I told examples also, like distance comes under scalar, and vector is what? Displacement, velocity. Okay, velocity, force, all these comes under vector quantities because these will have magnitude as well as direction and they obey vector law of addition also, right? So general way of representation is what? A vector, if it is there. Suppose A, if it is a vector, it is a physical quantity, and if it is a vector. Okay, general explanation I am taking. So if it is a vector, we will represent in this fashion in writing. So A, and it is direction also we are mentioning with one arrow. So if we want to write separately with magnitude and direction, as I am saying, it will have magnitude and it will have direction. So we will be representing in this particular way. A and its direction a cap. This whatever a cap we have written, this we call it as a unit vector. Okay. So unit vector also we had previously. Unit vector means what? Unit means one. So its magnitude will be one, direction will be same as the given vector. Okay, it is just like a supportive, right? Now, example means the best example is when we are writing sentences in English, we will be using some what we call is helping verbs will be using am, is, or like that. It will be supporting the total sentence. Same way, this unit vector will support this magnitude so that it will become direction. It will give completeness to this, right? Like same way, how we are using these helping verbs to give complete meaning to the sentence. So here we will be using this unit vector to get a complete meaning to this vector. Okay. Now, suppose if I want to write an expression for this unit vector, what do we write? A cap is equals to a bar by a we will be writing. Okay. And this a cap can also be written as a bar by a is what? Magnitude of this vector, no? So that magnitude of vector can also be represented in this particular way. Magnitude of a bar vector. These both are same expressions. Okay. So this is about vector. And I said about orthogonal vectors. Orthogonal vectors are the vectors which come along the different axes, x-axis and y-axis and z-axis if we have. So what did we mention there? Orthogonal vectors. Suppose we have taken this as x when three dimensions, when we are taking x, y, and z we have taken. Along x, if we have to write anything along x, so we have written I cap as unit vector, and along y if we write something, so what we have written? J cap as unit vector, and along z we have written k cap as unit vector. Okay. Suppose that, what does it mean? If we walk for 2 meters along x axis, so what do we write? 2 I cap we will write. Okay. Then after walking 2 meters, if we walk 3 more meters along y axis, then we will write 3j cap. This is what our displacement vector, right? So this is how we represent a vector in terms of these orthogonal vectors. Okay. So that is about orthogonal vectors concept. Now we will be using these orthogonal vectors are also unit vectors only, whose magnitude will be 1 and given direction will be along these axes. Okay. Now we will be using all of them. These are all completed. I'm just giving a review of this, and we will continue further. So what is our topic now? We want to multiply vectors. Suppose here we have a vector A. Such a vector if we have, such two vectors if we have, how do we multiply them? Okay. So when we are defining multiplication of vectors, we have to speak about two things. Here, multiplication of vectors is of two types. I will mention both of them and we will go with one. So here, vectors can be multiplied in two ways. When I multiply two vectors, if the resultant is vector quantity, or if the resultant is scalar quantity. So what happens? If the resultant is scalar quantity after multiplication of two vectors, that multiplication we call it as a scalar product. Scalar product. If two vectors are multiplied, if the resultant is a scalar quantity, then we call it as a scalar product. Means vectors only we are multiplying, the resultant is a scalar. Right? Next, if two vectors are multiplied, if the resultant is a vector quantity, then we call it as a vector product. Okay. So there will be difference between these two when we will be studying when we are going in detail. And scalar product has other name. Scalar product other name is, we call it as a dot product. Okay, dot product. And vector product other name is cross product. When we are going in detail, we will understand clearly. Okay. Now first I will complete detailed information about scalar product, then I'll continue with the vector product. Okay. Now in this scalar product I'll go with. So scalar product. Now, so in this scalar product, what I said, if two vectors are multiplied and the resultant will be a scalar quantity, such a multiplication of two vectors we call it as a scalar product. Right? Now, suppose we have two vectors a bar and b bar. A bar, B bar, two vectors are there. We want to multiply them. Generally, multiplication, when we are writing 2 into 3, we will write like this. Okay? 2 into 3. This we call it as algebraic multiplication. Okay? So, normal multiplication. Here, what we are taking? Vector multiplication I am speaking about. In that vector multiplication, when we are using, we have two types. So, we have to separate. So, that separation will be done with this. Okay. So what we are speaking about, we are speaking about scalar product, nothing but dot product. So that we will be putting one dot in between. This dot should be visible when you are writing scalar product. Okay. This dot is also mandatory when we are writing. If you have not keeping this, it can be treated as wrong only. Okay. Now, so A bar dot B bar is equal to, we will write it as magnitude of A, magnitude of B, and cosine of angle between the given two vectors. What are the given two vectors? A and B. Okay. So the how the two vectors are aligned also will be taken into consideration when we are taking product, whatever product it may be. If it is a scalar product, we will take cosine of the angle. As per definition, what we are speaking, scalar product is the two vectors, if they are multiplied under scalar product or dot product, so it can be taken as the product of magnitude of the two given vectors and cosine of the angle between them. Okay, cosine of the angle between them. Now, here magnitude, how to find magnitude I will come back, and the cos angle will be given in the problem when we are going with a problem. If they are asking us to calculate what is the angle between the given two vectors, if the two vectors are given and if they are asking us to calculate what is the angle between them, so for that we will go with this cos theta is equals to, no, cos theta is equals to, what we can write, a bar dot b bar, a bar dot b bar by a b we will write. Okay, that means vector, two vectors has to be taken, we have to multiply them, and we have to take their magnitudes and we have to multiply them. If we take ratio of them, we will get cos theta. Once we get cos theta, based on cos theta value, we can say what might be the angle. So still we can write theta is equals to cos inverse of what we have here, a bar dot b bar by magnitude of a into magnitude of b. So only for vectors we will put the dot here. We don't need to put it because it is not vectors, it is magnitude, right? Now, so there are some properties of vectors in scalar product. We will see them and we will continue. Okay. Now, in this, we have to take cos here. If two vectors are multiplied and they will be having positive value when they are multiplied, if the angle between them is acute angle. Acute angle means what? Acute angle means what? If theta is less than 90 degrees, if theta is less than 90 degrees, just hold on. So what I am speaking about properties, if theta is less than 90 degrees, that means if angle between the two given vectors is acute, then the two vectors multiplication, the scalar product of the given two vectors is positive. Okay, we will get positive value for the multiplication, whatever we are doing here. Next, if the two vectors are aligned in such a way that the angle between them is obtuse angle. Obtuse angle means what? The theta is the theta is angle between the two vectors is greater than 90, greater than 90. That means it is greater than 90 degrees and less than 180 degrees if it is there. So in such a case, the vectors which we are multiplying under scalar product, the resultant will be a negative value. Okay, we will get in terms of negative. Okay, so that is about two simple properties. And vectors, if they are multiplied under scalar product or dot product, they will be commutative. Okay, so two vectors, if they are multiplied under scalar product, they are obey commutative law or they are commutative. Commutative means what? A bar dot b bar, if I do a bar dot b bar, if I do, then which will be equal to b bar dot a bar, b bar dot a bar, right? So are you getting what I'm trying to say? A bar dot b bar will be equal to b bar dot a bar, right? Now, now that means what? 2 into 3 if we do, 3 into 2 if we do, it will be equal, no? Generally. 2 into 3 and 3 into 2 will be equal in general. 2 into 3 will be equal to 3 into 2. So this is algebraic multiplication, right? So algebraic multiplication, 2 into 3 will be equal to 3 into 2. Now, so this is not true in case of vector multiplication, but it is true in case of a scalar product. That means it may not come same in case of when we are studying about vector product. 2 into 3 will be equal to 3 into 2. Both the value will be equal to 6 only. Here also, this such a law we call it as commutative law. So commutative law will be obeyed in case of scalar product. A dot b if you do, b dot a if you do, we will get back to same value, right? Now, so some more properties will be there that we will see and continue. I'll go with the next page. Now, next properties. Distributive law also will be obeyed in case of a scalar product. Distributive law means what? A bar dot b bar if we take a bar dot b bar plus c bar if I take, which will be equal to a bar dot b bar plus a bar dot c bar. Okay, so dot is mandatory. So this is called a distributive law. Distributive law also obeyed in case of a scalar product. And anyhow, theta value I have mentioned. And one more thing, if if given two vectors are parallel to each other, parallel to each other means what? If a bar and b bar are parallel to each other, what will be the angle between them? So the angle between them will be 0 degrees, right? Now, if the angle between them is 0 degrees, if A bar and B bar are parallel, angle between them becomes 0 degrees. Cos 0 will become 1. So A bar dot B bar will be maximum. A bar dot B bar is equals to A, B we will write. AB cos 0 is 1. So AB we will write. So this is maximum. Okay. Next, one more thing what we write, if A bar and B bar, if A bar and B bar are anti-parallel, if A bar comma B bar are anti-parallel, so what happens? Angle between them becomes theta is equals to 180 degrees it becomes. If they are uh, anti-parallel to each other, so what happens? So cos 180 degrees will become minus 1. Okay. Uh, cos 180 degrees will be minus 1. So the vector product, sorry, the scalar product, the two vectors which are multiplied under scalar product, their value will be negative. Cos 180 will be minus 1. Okay. So AB into cos 180 minus 1. So minus AB it becomes. So if two vectors are anti-parallel to each other, their scalar product will be negative. And one more we can mention over here, if two vectors, if A bar and B bar are perpendicular to each other, if A bar and B bar are perpendicular to each other, so what does it mean? That is theta is equals to 90 degrees. In that case, what we can write, A bar dot B bar will be 0, because cos 90 degrees is 0. So AB into 0, it becomes 0 only. Okay. So A bar dot B bar becomes 0 when the two given vectors are perpendicular to each other. And we can check with the multiplication of vectors in case of orthogonal vectors also. Like if we am speaking about two given vectors, orthogonal vectors. Now, so the two given orthogonal vectors, it can be anything like I, J, K, out of them anything. So general way I am treating here. Suppose two given vectors, n cap I am considering here. N cap is one vector and one more is also unit vector. Two vectors are multiplied under dot product. If two vectors are multiplied under dot product, if the two vectors are parallel to each other, if the two vectors are parallel to each other, what happens? Theta is equals to 0. So what happens? Theta is equals to 0 means 1. And what will be its magnitude? N cap magnitude. When we are writing scalar product, what we have written? A bar dot B bar is equals to A B cos theta we have written, right? Now, if these two given unit vectors are parallel to each other, that means this is also along x-axis, this is also along x-axis. What happens? Already they are unit vectors. What is its magnitude? 1. And what is its magnitude? 1. So A vector magnitude, B vector magnitude, and cos of angle between them. So here I will write a algebraic form only, 1 into cos. What is angle between them? Parallel means 0 degrees. So 1 into cos 0 is also 1. So what happens to this? It will become 1. So n cap dot n cap will be 1 if they are along the same axis. So that means what? I cap dot I cap will be equal to 1. And next, j cap dot j cap will be equal to 1. Okay. Next, k cap dot k cap will be also equal to 1 only. Right. So that is about orthogonal vectors multiplication. Now, under this only I will write one more thing. If the two orthogonal vectors, if the two orthogonal if the unit vectors are orthogonal, here two unit vectors only, they are not orthogonal, they are along the same axis. If orthogonal vectors, for orthogonal orthogonal unit vectors, for orthogonal unit vectors if I speak, for orthogonal unit vectors, what we can write? N cap dot n cap can be written as, what we can write? I what is its magnitude? 1. Okay, and what is other one magnitude? This unit vector also magnitude 1 only. And so as they, I am mentioning that they are orthogonal, what is the angle between them? The angle between them is 90 degrees. Okay, one is along the x-axis, other one is along y-axis. It means, so cos 90 value is 0, so total value becomes 0. Okay, so n cap dot n cap became 0 here because they are orthogonal. So generally if we write I cap dot j cap is equals to 0, and j cap dot k cap is equals to also 0, and next one is what? K cap dot I cap is also 0 only. Okay, as they are orthogonal, all those are orthogonal vectors, so their dot product will be equal to 0, right? So anyhow, I cap dot j cap or j cap dot I cap, two different unit vectors are coming, means their multiplication in case of scalar product becomes 0, right? So that is about multiplication of vectors, and we have done with the orthogonal vectors also. If we take multiplication in terms of its components means what? I'll give you one more property, then I'll go with one example so that the scalar product will be completed, so that we can move with the problematic part. Suppose if we take two vectors a bar and b bar in terms of their components, if a bar if a bar is equals to ax I cap plus ay j cap plus az k cap, and next b bar also I am taking another vector b bar is equals to bx I cap plus by j cap. Okay, bx I cap, by j cap, and bz k cap. So bx I cap, next same way, if we write in the same way, what we will get? By j cap, no, by j cap, other one is bz k cap, right? Now, so if we multiply them in scalar product, what do we write? A bar dot b bar, if we write, so ax I cap plus ay j cap plus az k cap, right? Now into dot, here we have to put because we are multiplying them in scalar product. Bx I cap, bx I cap plus by j cap plus bz k cap, right? Now, so what we will do? I cap and I cap will if we multiply it will become 1, and I cap and j cap if you multiply it will become 0. Same vectors means it will become 1, other vectors means it will become 0. So anyhow, other vectors, other unit vectors, if we multiply it will become 0 only, so we don't need to multiply them directly. Same vectors multiplication only will do. Ax into bx I cap dot I cap becomes 1. So I cap dot j cap becomes anyhow 0, so we won't go with them. So I cap dot I cap anyhow 1, I am not mentioning that. So ay into by, next az into bz. So directly we will go with this. If two given vectors are if two given vectors are there, if we have to take scalar product of them, so we will take in terms of components, and we will directly write I cap coefficients, j cap coefficient, k cap coefficients. We will multiply and write. That is that simple scalar product is. Okay, so that is about the scalar product and its properties. If we go with one example, so where we will come across this? So this already it comes in the our next chapter. Suppose if two vectors are there, force and displacement, force and displacement, two vectors are there, and if we multiply them in scalar product, if we multiply them in scalar product, what happens? F bar dot s bar is equals to, what we write? F s cos theta we will write. Okay, so fs cos theta we will write. This is what we define it as a work. Okay, now, so we can still we can make one more derivation part also out of this, right? So we can make one more derivation part that we will do when we are doing the chapter itself. This I am just giving one example where we use it. Okay. So if two vectors are there, if we have to take scalar product, we'll write magnitude and cos of angle between them. Right. So that is about a general example where we use this scalar product. Okay. So we will solve some simple problems on this and scalar product, and I'll continue further.